I would like to introduce to you the CRM-geothermal project, give a rough overview over the whole project, the project aims, and also the work packages before we go then into detail with the other talks on work package 1 and 2 to provide you with a bit more detail. So CRM-geothermal is a project on raw materials from geothermal fluids, occurrence, enrichment, and extraction. And we face a challenge that large amounts of critical raw materials are needed for the energy and for the digital transition. For example, as you see in the picture here, if we go from combustion engines to electric vehicles, we will use a lot more copper, lithium, nickel, mangan, cobalt to build these electric vehicles, and also for these wind turbines, for example, we need a lot of critical raw materials. For example, also the rare earth elements, which we don't produce in Europe at all. So the CRM-geothermal solution that we are suggesting is the extraction of critical raw materials from geothermal fluids, and we answered with this project to a call from the Horizon Europe program on innovation for responsible EU sourcing of primary raw materials. We secured roughly 7.9 million euro funding from the EU, the UK, and Switzerland, and the project started in May 2022 and will last until April 2026. The concept is relatively simple. So CRM-geothermal proposes to combine the extraction of heat and electricity and the extraction of valuable elements from geothermal fluids, with the clear advantages that we would maximize the returns on investment for geothermal operators. We avoid additional land use because geothermal power plants are comparatively small compared to traditional mining, and we also minimize environmental impact of mining. The project has 20 partners, which you can see here. We are from the EU, but also Switzerland, UK, Turkey, Iceland, and even Kenya, and with the 19 affiliated entities of the European Federation of Geologists, we are covering then 23 countries altogether. The partners come from academia, universities, research institutions, but also from companies, from geothermal operators, and also some associations. The objectives of the project I would like to introduce now. So the first objective is to establish an overview of the potential for raw materials in geothermal fluids, to really find out which raw materials are included in the geothermal fluids and which different settings, and to establish then a fluid atlas from that. We also would like to determine the source of selected CRM, their mobility and potential for sustained extraction from geothermal brine. We are looking at leaching experiments, for example, and really look into some of those geothermal systems in more detail. We develop and optimize innovation extraction technologies for selected CRM, and then assess the environmental, social, economic viability to foster the ethical sourcing of CRMs. And finally, we would like to demonstrate at a pilot site the extraction technology at the scale of a mini plant. And now I would like to go into the single work packages a bit more in detail. So the first work package is screening and mapping of CRM content in geothermal settings. So this work package is really about the data collection and the database creation. We want to have a database with different fluids and cover almost all the CRM that are listed by the European Union. We sample and analyze liquids, gas, and solids, so not only the fluids itself, but also the host rock and in part also the scales. And then we establish the CRM-geothermal fluid atlas for Europe and East Africa, which is mainly based on the existing Reflect fluid atlas, which we developed in a previous project, and now we build upon this Reflect fluid atlas and add more critical raw materials and also extend it to the East African Rift. And finally, in work package 1, we also have the AI-based simulation tool, so the predictive analysis of data using artificial intelligence or machine learning tools. And in the next talks, Anna and Kelly will go into the details of the work we are doing in work package 1. In work package 2, we determine the source of selected CRM. So we are now narrowing it a bit down and only look at a few CRM. We want to obtain better knowledge of the geological and geochemical controls of the CRM enrichment in geothermal environments. We look at these 5 different focus systems, so the sedimentary basin systems, the crystalline rocks, the high enthalpy volcanic systems, the sedimentary and high enthalpy systems, and finally the continental rift with the alkaline fluids. We also do host rock analysis here to track the source of the CRM in the fluids and do these leaching experiments to determine the rates of dissolution to evaluate the long-time sustainability of the CRM extraction. Then the work package 3 is really the development and optimization of extraction technologies for CRM from geothermal brines. We have 6 different extraction technologies, which are all a bit on a different level of development. The first one is the absorptive extraction by ion sieves. This is done by GFZ and ISTEC. And here we focus mainly on lithium and strontium. The second one is selective ion exchange membranes by the University of Padua. Also, they focus mainly on lithium and strontium. And then we have the adsorption by means of modified biopolymers with crown ethers. Here the focus is a bit on different elements. We want to look at rubidium, gallium, and germanium. Then the bioextraction and bioaccumulation, so the usage of microbes to enrich or extract CRMs from the brine. There's a main focus on lithium, but they want to possibly also look at other metals like strontium, copper, gold, antimony. The next one is the helium extraction by membrane technologies. So here we clearly look at helium and how to extract it in both cases when it's dissolved in the fluids, but also if it's already degassed and extracting it from the gas phase. And then the last one is gas diffusion electrocrystallization. It's a technology developed by Vito. They focus on lithium, but also on strontium, rubidium, and possibly even the rare earths. And this GDEX technology was already tested in various EU projects before, so they are already a bit more advanced, and they reached 70 to 99% lithium extraction from natural occurring geothermal fluids. In the picture, you can see one of our tools that we are using. So this is a fluid flow monitor and reactor unit for storage and flow of fluid under high pressure, high temperature conditions. And then the fluid is passing through an adsorption column, and we can test in this setting really the adsorption and the extraction of lithium and also other elements at in situ conditions, so really at the temperature and pressure that is occurring in the geothermal operations. I would like to announce here also that for the work package 3, we will have a joint webinar on 12th March at 10 o'clock together with a raw mina project. So with a raw mina project, we are collaborating in the cluster hub for the production of raw materials for batteries. And raw mina is focusing on recovery technologies from mine waste. We are, as you know, focusing on recovery from brine, so from geothermal brines. But there are, of course, some things in common, and that's why we have a joint webinar with them. The first talk is going to focus on composite nanofibrous materials for extraction, and our colleagues from the University of Padua will present new ionomers for the extraction of critical raw materials. With that, I would like to go forward to the work package 4. that is about the deployment of combined extraction for CRM and energy from geothermal fluids. So it really looks a bit more into the general aspects, for example, the framework conditions on environmental, social, and governance aspects that will be assessed. The aim of this work package is also to develop a UNFC compatible reporting scheme so that it's also better comparable to traditional mining. We have a task on how to obtain and maintain the social license to operate. So in this task, they are also looking at natures and drivers of resistance or support for combined extraction. And finally, it includes a macroeconomic assessment of the potential of combined extraction compared to conventional mining. And at this point, I would like to ask a question to you as the audience and to also engage a bit more with you. So where do you see the largest challenges for co-production of CRMs and geothermal energy? And we would be happy if you could use the chat to answer this question, to provide us with your opinion, and maybe we can also follow up on this and after the talk in the discussion. And then I will continue with work package 5. Here we really want to apply what we found in a real life system. So it's about demonstration and testing. In the work package, we we look at the pilot site for CRM extraction, and we started with hydraulic testing and geochemical monitoring in June, July 2023, and I will tell a bit more about this in the next slide. And also we look at process engineering aspects at a mini plant scale. So in this mini plant, we want to combine for example, the whole process as adsorption and desorption in one mini plant to really have the whole process in one in one test setup. And finally, the work package also includes the application of social concepts. As I said, we had a site characterization and testing in Cornwall in June 2023. This one consisted of 2 specific tests that were used to test the system. So the first one is the airlift testing, where pressurized air brings the fluid to the surface. And here the aim was to determine maximum flow rates of the exploration borehole by simultaneous measurement of the flow rate. And then we estimated the productivity index to 46 to 61 meters cubed per hour and bar. and the second one was a push-pull tracer testing. Here we injected an inert substance into the borehole and then back produced it from the same borehole. The results indicate that the reservoir is extremely permeable. You can see from the graph here that we have a first phase, this push phase, where the tracer is injected. So you can see that we injected this yellow area of tracer. Then we injected also a chaser, so some clear water, and then stopped pushing, so stopped injecting into the borehole and started the pull phase. And at the end, at what is it, 1419, you can see it's a very small peak of tracer that has been back produced. So essentially all the tracer was lost in the formations. And this indicates that the reservoir is extremely permeable with high groundwater flow. So everything is really flowing into the formation. And during the test, we were also monitoring the fluid composition of both wells. So they were using 2 wells for the tests. And the fluid composition is really similar to seawater, but enriched in lithium, iron, and also fluoride. And with that, I'm coming to the last work package. We have also the dissemination and communication and exploitation work package, where we communicate our results to the public. Currently, we have the video contest for 12 to 18 years students open. If you have a look at our website, you can find this video contest, and we invite students to produce 2-minute long videos, and also have some nice prizes for the students. So if you have children, nieces, and grandchildren, or just friends, then we would like to ask you to recommend our video contest to the young ones. And I would like to close my presentation with the expected impacts from the project. You can see that the combined extraction has the potential to cover a significant percentage of current and future needs of CRM to the European Union. With a combined extraction, we would foster a more resilient and domestic CRM supply chain, and by that also reduce imports exposed to market and political risks. We could also, by kind of exporting the technology out of the European Union, create more trustworthy and ethical supply chains for certain CRMs that are really not producible in the European Union. We help to bridge the gap between societal resistance to raw materials extraction and the increasing demand for raw materials. And finally, by increasing the returns on investment, we also expect a greater number of viable geothermal projects. And with that, I would like to thank you for your attention.